I am building my very own hypothetical model rocket. The reason I call it hypothetical is because as of right now, I have no intention of creating physical versions of any of the components that I design in this series. In the future, however, I hope to use what I've learned in this project to create better versions of these components and produce a better final product. Think of this series as a rough draft for a future custom model rocket, or as a learning project for me to become familiar with CAD software, in this case I'm using OnShape, and computer hardware and software, in this case I'm using Arduino. This being my first episode, and likely my worst design throughout this entire series, I've chosen a component that is not largely critical to the rest of the launch system. Just in case something goes wrong, or I just create an unsatisfactory final product, it isn't the end of the world and it can be excluded from the final design. What I'm building today is the launch hold-down clamps. In real rocketry, these structures maintain a firm grip on the vehicle all the way from assembly on the launch pad to T0 when the rocket lifts off. They are necessary for most liquid rocket engines, as the startup transients immediately after ignition are incredibly dynamic processes. Not only is the rocket not yet producing its full amount of thrust, and therefore is not powerful enough to be released from the launch pad and support its own weight, there are lots of things that could cause an abort during these critical few seconds. And if the rocket engine shuts down its engines prematurely in an abort situation, and it's not connected to the pad, well, it could be a very bad day for the rocket designers, and whoever's on top of the rocket. For model rockets, however, this simply isn't as critical. Most model rockets use hobbyist Estes motors. These motors, once ignited, typically reach their maximum thrust instantaneously, and for better or worse, cannot be shut down after they have been ignited. This is why it's perfectly safe to launch a model rocket whether or not it's actually connected to the launch pad that it's lifting off from at all. However, this isn't stopping me from building one. It, of course, adds many unnecessary failure points to the entire design, but hey, it's a learning experience, and that's what this whole project is about. Now, let's take a look at the final design itself. Here I am in OnShape Studio. The final product consists of 4 components: the housing, the swing arm, the block, and the drop pole. These come together to form the component you are seeing here. I did not mention the servo, which enables the entire system to work. This servo is a standard SG90 motor design, which comes in most starter Arduino kits. First, let's take a look at the housing. It's all printable in one piece. The front section is shielded from the hot rocket exhaust to protect the more intricate components such as the servo from the rocket. Inside, there are 2 grooves on either side, which allow us to slide the rotational bit of the swing arm into place. The housing serves as one half of the rotational bearing for the swing arm. Now let's take a look at the swing arm itself. It's an incredibly simple design with the following dimensions. The only thing to note are these 2 extruding cylindrical surfaces that allow the structure to be connected and form a rotational joint with the housing. Here are the block and drop pole. As you can see, the orange swing arm is inserted from the back. Then, the block is inserted to hold it in place. This allows for a system that is not only entirely 3D printable, but also assemblable after the fact, without any glue or adhesive. Then, the servo is installed. Viewed from the bottom, there is a small opening that allows all of the servo's wires and connections to the Arduino board to be inserted through the bottom of the launch pad. Attached to the servo is the drop pole. It's simply a servo extension, so it can reach the swing arm. As you can tell, the drop pole has a slant towards its top. This ensures that the servo rotates in the correct direction and is not pushed the wrong direction by the force of the rocket pushing against the swing arm. So how does the whole system work? Well, once the rocket begins to launch, it is still held down by the clamps. There is currently no connection interface to the vehicle, but it would go on this face of the swing arm. When the swing arm is commanded to release the rocket, 2 things happen. Firstly, the drop pole is removed by the servo. The servo is commanded by the Arduino board to rotate 90 degrees. Once this happens, the large upward force on the swing arm, imposed by the rocket, is no longer resisted by any force, and therefore the swing arm rotates down into this position. The rocket is therefore released from the launch pad. Now let's take a look at the code itself. This code is incredibly simple, and pretty much what you're looking at is code that tells the Arduino to turn the servo 90 degrees to the left. So was it really worth creating in this instance? I don't think so. because typically what we want to do is write the entire launch sequence code and then embed this more simplistic code inside that. It makes no sense to run an entire Arduino board just for the hold-down clamps. So just keep that in mind as I tell you how this works. Essentially, the first thing we do is include the servo library. This is how the Arduino knows what servo we're operating with and how to talk to it. We then declare our servo variable as a global variable. We then declare an integer, which is our commit pin. Now, what is this? Since this code isn't embedded in a much larger countdown sequence, which it will be at the end of this project, this is pretty much how we tell the Arduino board, hey, the much larger code that is running the primary functions of the countdown just said the countdown has reached 0 and you're supposed to release the hold down clamps. What the commit pin is essentially a pin on the Arduino board that, if it receives 5 volts, or a high voltage as it is known by the Arduino board then understands that the countdown has reached 0 and it is supposed to release the pin. It is essentially saying go for launch. Here in our setup we are attaching the servo variable to pin number 5 on the Arduino. We are first commanding it to go to 0 degrees just in case it isn't already. We are waiting 2 seconds to start the entire program, and we are telling the Arduino to read the voltage from the commit pin. Finally, in our loop we have a simple if statement, which of course will be, as I said many times, much different in the final larger version of the code, where this section is only a small embedded portion. It is saying if the commit pin is high, or at 5 volts, then we jump down to a function called release. Release, in this case, of course, referring to the hold-down clamps. All it does is say servo, go to 90 degrees, then wait 1 second. I've tested this and it works, and it's incredibly simple, but it doesn't need to be any more complex than this. So that is my design for a launch hold-down clamp for a model rocket. It's not perfect, but it's a great way to teach myself CAD and Arduino. For the next episode in this series, I'll be committing myself to creating something that is a bit more important for the model rocket itself. Thank you for watching, and I'll see you next time.